All right, so probably the most important thing when we're going to talk about chemistry are these unions between atoms, and the union of these atoms form molecules, right? And so chemical bonds are really important because as we're going up our organizational levels of life, we need to know how molecules are formed, right? And so how one element's atom interacts with another atom depends upon the number and arrangement of their electrons. Remember, those are the negatively charged particles that are orbiting around the nucleus. And we're going to use a very old model to demonstrate this. It's called the electron shell model. And if you take chemistry, and if you took chemistry in high school or whatever, you probably didn't learn this because it is old way to look at things. It's not as accurate, but it does help us in biology show how these atoms interact. All right, so we're going to use the electron shell model. Electrons vary in amount of energy that they possess. Electrons occur in certain energy levels. Okay, we're going to call those electron shells. Depending upon the number of electrons an atom possesses, it may contain one or more electron shells. The first shell or energy level can hold up to 2 electrons. That's once it's filled, it can't have any more electrons. So if there are more electrons that the atom possesses, then they get bumped to another energy level, right? So the second energy level or electron shell can hold up to 8, all right? And so if your atomic number is 7 and the first shell can hold 2, then the second shell, the second electron shell, can hold up to 5, right? 2 plus 5 is 7, right? And so once that second energy level or shell is filled, then if you have more electrons, they're bumped up to another energy level or electron shell, and it can hold up to 8. The goal of bonding and just atoms in general forming molecules is the fact that they want their outermost electron shell full. It's like they'll be fully satisfied at that point. It's like after Thanksgiving dinner. And those that have full electron shells are called inert. They don't react very easily with others because they're fully satisfied, right? And so if there are differing number of electrons in their outer shell than a full complement, then those atoms tend to make bonds with others, right? So we want to form those bonds. And so sulfur has a atomic number of 16. All right, so if your atomic number is 16, the first shell will hold up to 2, and that leaves us 14 electrons. Then the next shell can hold up to 8. So we have the first shell have 2, the second shell has 8, so that leaves us 10. So in the next shell we have 6 left over, and those would go into the third shell, right? So for your exam, I'm going to ask you if I'll give you an element with an atomic number, and I will ask you how many outer shell electrons there will be, right? This will be something probably less than 10, all right, the atomic number. So you'll need to know how many outer shell electrons that atom possesses. So let's look at carbon, right? We already said that its atomic number is 6. If it has 2 electrons that go into the first electron shell, then what's left will be in the second electron shell, and that will be 4, right? And so I'll give you atomic number, you tell me how many outer shell electrons. This is the most important thing because it deals with the forming of chemical bonds which make molecules, right? And so this is just a diagram of sulfur, and we see in the first shell we have 2 electrons. It's full. So now the remaining go out to the next shell. The next shell can hold up to 8. All right, so it's full with 8, and we have 2 in this first shell, so that's 10 altogether. So the last 6 are going to be in that outer shell. So if the outermost electron shell is unfilled, then the atom tends to form bonds with other atoms so that their electron shells can be filled, right? The bond forms when an atom either gives up or gains or shares outer shell electrons. And the types of chemical bonds that we have are ionic, covalent, and hydrogen. So ionic bonds. Ionic bonds are formed when one or more electrons of outer shells are donated by one atom and to fill an outer shell of another atom. All right, so one atom donates, one atom accepts these outer shell electrons to help fill their outer shell. Then the balance between the protons and electrons of the involved atoms shift, right? So what happens is we get more electrons in one, the one that gets the electrons, and then the one that donates the electrons has have less electrons now. So we have this imbalance between the electrons and the protons, right? So when you have this, now you have filled outer shells for both of the elements. But if one has more protons than electrons, that atom will become an ion, and it will have a slight positive charge. Likewise, the one that got the electrons will have more electrons now than protons, and it will have a slight negative charge, right? And just like with the electrons and the nucleus, right? We had differences in electromagnetic charges. Now the positively charged ion and the negatively charged ion will be bound together to form a ionic bond because they have difference in electrical charges. And here's a diagram between sodium and chlorine. All right, sodium has an atomic number of 11. Chlorine has an atomic number of 17. Right, and so in order to get a full complement for chlorine, all it needs is one electron in its outer shell. So when sodium and chlorine come together, chlorine just rips that outer shell electron out of its orbit around sodium and puts it on its own outer shell. And this is the formation of an ionic bond, right? And what happens is now, if you look at the sodium who donates the electron, now it has a second shell that's fully complement, that has full number of electrons, and then you look at chlorine, and it has a full outer shell of electrons. But if you count the number, sodium has an atomic number of 11, therefore 11 protons. If you count the number of electrons now that the sodium atom has, it has 10. So there's more positive charge than negative charge with this particular atom. So now it's an ion, a positively charged ion. And then if you look at chlorine, it has atomic number of 17, so 17 protons. But if you count the number of electrons around it now, there are 18. So it has a negative charge. So both of those come together in union to form sodium chloride. And sodium chloride is table salt. So covalent bonds. Covalent bonds are bonds where two atoms need outer shell electrons, but they don't have enough attraction for their partner's outer shell electrons where they can't pull it out of the orbit, right? So they're not as the attraction for those outer shell electrons is just not strong enough to pull it out of the electron shell. And so since they can't pull it totally away from the other atom, they share those outer shell electrons. And a molecule, we're going to say, is two or more atoms held together by covalent bonds or chemical bonds. We talked about it being a cluster of atoms, but now we're going to talk about it as atoms being held together by chemical bonds. And a lot of the more important molecules in life are covalently bonded molecules, right? Where the electrons are shared, not donated and accepted, right? And so atoms in a particular covalently bonded molecule are in constant tug of war for those shared electrons. Sometimes one atom might have a greater pull over those shared electrons than others, but they're always in a constant pull of trying to get those electrons around their nucleus as compared to their neighbor in the bond around their nucleus. And this energy, this attractiveness of electrons in a covalent bond is called an electronegativity, right? Those atoms in a covalent bond that have higher electronegativity will tend to have the electrons in the outer shell that are being shared disproportionately around them versus the one that has less electronegativity. Just think of you're driving to Utah in a car, and you have two children. One's 3 and one's 1, and they're in the back seat with a toy that they both want, and they both grab the toy at the same time, right? They start tugging at the toy, each one at that toy to get that toy for themselves, and sometimes it will not be shared equally, because probably the 3-year-old will take the toy away from the 1-year-old for a while, and he gets the first chance at playing with the toy, then can share the toy with the 1-year-old later. So this is sort of how the atoms work. They share these electrons, but sometimes they're not shared equally. So there are bunches of, or different types of covalent bonds. There's a single covalent bond where two atoms share electrons. They just share one pair of electrons. Some just to get you to know some like shorthand. If you see a H with a dash and then another H, that means that there's one covalent bond shared between those two atoms, right? For shorthand version, you might see H2. That means that there are two hydrogens and there's one covalent bond shared between them. You really can't tell if you have H2 whether there's just one or if there's more than one covalent bond, but a lot of times you will see that abbreviated in the structure of a molecule, because it's just so much easier to write than write all of the little dashes and things. There's double covalent bonds when there are two pair of electrons are shared between two atoms. Oxygen shows here shows up with an equal sign. An equal sign means that there are two pairs of electrons that are shared. But if you look at the shorthand version, it's O2, so you don't know that there are two covalent bonds there. Nonpolar covalent bonds. These are covalent bonds that are formed between atoms most of the time of the same element, because when those covalent bonds are formed, they're equally shared between the two. They have the same electronegativity, so when they share electrons, they share them equally, and there's no tug of war between those shared electrons. So as up here at H2, where you have two hydrogens sharing a pair of electrons, you can see that they form a non-polar covalent bond between the oxygens as well. Again, they have the same electronegativity, so they share those two pairs of electrons equally. So here's a nonpolar covalent bond of hydrogen, and you can see that most of the time, since they have the same charge, same electronegativity, they're not going to form, they're not going to have this constant drastic tug of war between the two atoms. However, when atoms of differing electronegativities are formed, forming a particular molecule, sometimes there's an equal or unequal electronegativity between the atoms, and if this happens, then there's unequal sharing of those outer shell electrons. And so participating atoms exert differing electronegativities on the shared electrons, in which the atom with the more protons attracts the electrons more. It has more of a pull for those electrons because it has more protons. And if it has a more pull, it has higher electronegativity, then those electrons that are being shared will actually orbit around the more positive area more frequently than the smaller, less electronegative atoms in the particular molecule. Water is a very good example. H2O. So oxygen is atomic number 8. Hydrogen is atomic number 1. They have varying numbers of protons and varying electronegativities. Since oxygen has more protons, more of a pull, then they will have the shared electrons around them more often than around the hydrogens.